How does this bridge hold my weight?
Man, I really don't know.
Actually, I know this guy named Joe Katowski. He used to be a mechanical engineer. Maybe he knows.
Let's ask him. Hey, Joe, nice to meet you. Any chance I can ask you a few questions?
Yeah, let's step into my office.
You're the brilliant and handsome Joe Katowski, mechanical engineer. So, Joe, what type of schooling is needed to get this job?
You need a bachelor's degree. I got mine from U of I, but I got my optional master's degree from Northwestern University.
Competitiveness is like in the mechanical engineering field.
Like the gym, mechanical engineering is a highly competitive field with an above-average job market. In recent years, it's gained a lot of popularity.
Where's Joe? We still need to find the average starting salary of a mechanical engineer. Joe? He's not. Joe? Joe?
The average starting salary is $60,000, but some make up to $80,000.
Joe, so what are the hours of a mechanical engineer?
It varies from company to company and project to project, but the average is about the normal workday.
Clearly, Joe has been putting many hours to engineering and not piano playing.
Hey!
Mechanical engineers are typically involved with generation, distribution, use of energy, the processing of materials, the control and automation of manufacturing systems, the design and development of machines, and the solutions to environmental problems.
Reporting live here is Joe Katowski himself.
If I get back to our example here, once again, you'll see the frame of the truss right here, right? So in this particular one, there are two bridge trusses, one on either side, and they are connected by the stringers going along the length and the floor beams, which generally are stronger. So the beams and the stringers transfer the load of the deck and everything on the deck, i.e. the cars and also the weight of the materials themselves of the bridge. And they will transfer the loads to the bridge truss. So you see these three guys right here? These three guys represent the transferring of these loads. Okay.
Here we have sample forces on the bridge. As you can see, the sum of forces in the x direction is 0 because the bridges cannot have acceleration. The pin here is for varying conditions such as snow or rush hour or strong winds.
Alright, so here's your bridge truss, and this AY has to be equal to the 4N in CY in order to be in equilibrium.
Alright, since the goal is to cancel out the forces in each level, horizontal and vertical, to cancel out the vertical ones, we take AY, which is here, set it equal to 400 plus CY. That will give us 0, which we want. Now to cancel out the horizontal force, we take CX equals 600.
Alright, so moment is force times distance. So here's your 400 Newton force times your 3 meter distance plus your 600 newtons times your 4 meter distance, and then you want to equal that to what you don't have, which is AY as your force you don't have times your 6 meters.
This is what it looks like written out. We are now going to pause the video while you solve. You should have gotten that AY equals 600 newtons. We will now pause the video if there are any questions.
Alright, so here's the bridge drawn in a bigger proportion. So now that we found the force of AY, this is the pin, and when you pull the pin, it has all the forces acted on it. So that gets your upward force of AY of 600 from what we just did. So now, looking at that, now that we know that is 600, we're solving for this triangle, and we see that this is 3, and then the height right here is 4, making that 5, so it's a 3, 4, 5 triangle. This gives you your inverse tangent of 4 over 3 because it's opposite over adjacent.
Alright, since vertical force AY is pushing up, that means we need an opposing force, which is FAB, pushing down. But since FAB is slightly to the left, we need another opposing force pushing to the right, and that force is FAD.
Alright, so to find your FAD, which is the force going to the right, you need the opposite of FAB, which is the negative cosine 3 over 5. As you can see when you look at the triangle, your cosine is adjacent 3, hypotenuse 5. So there's that. You plug that into the equation to find FAD.
We will now pause the video while you solve for FAB and the sum of forces in the y direction.
This is algebra.
Alright, so hopefully you guys got 750 newtons for FAB, and that is in compression, because if you look at your bridge, FAB is a downwards force, which means it's compressing on that pin.
Now substitute the 750 newtons for FAB into FAB and the sum of forces in the x equation. Now solve for FAD in the x direction.
Alright guys, so for FAD, hopefully you got an answer of 450 newtons, and that's a tension force. Because if you look at the graph of the bridge, FAD is moving to the right, which means it's pulling the pin, so it's a tension.
Thanks, Joe, for teaching us about mechanical engineering.
No problem, bro.
'Cause I'm coming at you like a